Yo, what's up, guys? Welcome back. Probably gonna be a little bit of a quicker stream. Ooh. Um, yeah, I think we're just gonna do a little bit of leak code. Probably call it for a day. Been working a lot on setting up a new project. Hang on one second. Yeah. Yeah, setting up a new project. I'm gonna be building a. Still gonna be doing the C++ stuff, but gonna be doing a lot of OpenGL on my own time. But maybe I'll show a little bit on stream. But um, gonna be working on a app for my fraternity. I was in a fraternity in college. I'm sure some people know, but gonna be working on an application for the Alumni Association to handle dues and keep up to date with the undergraduate chapter. So, I mean, set up that project all day. I've been working on the restaurant management system too. So, it's a little bit late, but yeah, just thought I'd do a little bit of leak of problems. So I turn on the stream and maybe solve the problem of the day, whatever that is. Let's take a look here. I think we missed some more from yesterday. Yeah, subrate detection 1. Let's take a look at this one first before we move on. Let's play some Spotify, baby. What should we play? Maybe some. Maybe something different, dude. Let's play some different lo-fi. Kind of tired though. Let's take a look at this problem here. Grab up the project here. The restaurant management system here. So let's take a look here. Adjacent increasing subarrays detection 1, given array nums and an integer k, determine whether the exists 2 adjacent subarrays of length k. So both subarrays are strictly increasing. Specifically, check if there are 2 subarrays starting indices a and b, where a is less than b, where both subarrays a, k minus 1, b, k minus 1 are strictly increasing. The subarrays must be adjacent. B is equal to a plus k. Turn true if it's possible to find 2 such subarrays false otherwise. So let's get an example here. So subarray starting index 2, 7, 8, 9, which is strictly increasing. The subarray starting index 5. So I'm guessing it's just like a sliding window. No. Is that what we're doing here? The result is true. Okay. Given an integer array nums and integers and an integer k, we want to determine whether there exist 2 adjacent subarrays of length k such that both subarrays are strictly increasing. 7, 8, 9, 2, 3, 4. So check if there are 2 subarrays starting indices a and b, where a is less than b. Both subarrays. I'm a little bit confused. Medium upvote should be a medium, I think. I'm trying to think about exactly what this is asking me to do. If it is doing what I'm thinking about, I think it should be a sliding window problem. It shouldn't be too bad, but let's get a better description here. You need to check if there exists 2 adjacent subarrays of length k such that they both are increasing, strictly increasing, and the second subarray starts immediately after the first one. Finally, you're checking if there exists an I, where 1, 2. Then we have 3, 4. It was also increasing. Output true. So build an array of increasing streaks, create an array. So I'm trying to think here, maybe we can maybe we have our input here, right? You can start off here, right? Start off here, grab these numbers, these 3, check. They're not strictly increasing, right? They're not 1 less or 1 higher. We move. Boom, boom, doesn't work. Here, boom, boom, works. We can set some sort of flag here, right? Maybe move 2 ahead, check here, here, and here. Trying to think here, what the best way is. -1 +1. Okay, let's grab this here. Let's create a private section here. So we don't actually have to return the indexes, so maybe we can just start with a basic sliding window, right? Left, right, we can go for int I is equal to 0, I is less than nums dot length, right? I plus plus. We can have like some sort of bounds check, right? So if I minus 1 is less than 0, or I plus 1 is greater than or equal to let's do like tan is equal to nums dot size. Have the size here to be n. Set this to be n. Then we can what? Like skip this iteration, right? Otherwise, what do we want to do here? Well, we want the length of it to be 3, so trying to think about this here. How do we go about with a sliding window? We can grab the 3 elements. God, I can't remember off the top of my head, dude, honestly. Let's check a classic sliding window problem here. What's the best way to do this? Well, we want to keep track of the size, right? How can we keep track of the size? While left, sorry, while right minus left plus 1 greater than K. Want to like move our window, right? I'm trying to think about this window here. Seems like my buddy's stopping at me. Our balance check here, we move our window. Let's take a look. Let's think about this. Well, we're just moving our window here, so well, actually at the element. Not enough elements for 2. We have a balance check here. Let's see here. We have a streak here, current increasing streak length. Eyes listen in. Am I overthinking this, dude? Maybe, honestly, we could probably just loop, right? Like, we can just... Instead of doing an actual sliding window, right, we do int streak is equal to 1. We then... If... nums I is equal to nums I minus 1. We increase the streak. Plus 1 is strictly increasing. We increase the streak. Otherwise, we make the streak equal to 1. AK minus 1, strictly increasing the surface must be adjacent, meaning B. Try to think, can they always be strictly increasing? Maybe they don't have to be exactly one above, right? Doesn't necessarily say that. Do if do here? Maybe if streak is greater than or equal to 2 times K, turn true, else. Oh jeez, return false, bless me. Return false. Let's see what that gives us here. Stake, streak. How am I spelling streak wrong? We count the first element, right? So we got 1. Oh, we have to start from 1, right? No. Yeah, we start from 1. We loot. Expected true. What do we get here? 789, 234. What are we doing wrong here? Num size, int left, streak. If num size equal to num size minus 1. Oh, equal. It should be if num size is greater than. Has to be strictly increasing. Says here. Size greater than num size minus 1. Streak plus or equal to 1. Else streak is 1. If the streak here is 2 times K, turn true. Maybe this should be greater than or equal to 2 times K. Bro, what is wrong here, dude? Not even using left anymore. I don't know why this is passing. Or at least... Num's I has to be greater than, yeah. I guess maybe in this case if we go 2, 5, 7, 8, 9. We should go 7, 8, 9. That's why. Probably need it to be unsquared, dude. Let's see here. I don't think this will pass, but let's see here. Maybe we can just do, fuck it, I'm just gonna do the n-squared approach. For int I is equal to j is less than n, j plus plus. Right, we can just do all this code here. What is going on here? Let's grab this code. j is equal to I. Whoops. Let's change this here. Nums j minus 1. Oh shit. Bro, I'm totally out of it right now. I'm trying to think right now. Okay, so we're given numbers here. Right, we loop 1, 2, 4, 5, 6, 7, 8, 9, 10. Right. We start at this number. We find the 3 that we need, right? Maybe we find these 3. Maybe we find this one, this one, this one. How would that work in terms of that? That's the thing. What approaches are people using? What is this? Longest substring? Oh, jeez. Not this one. This if is restricting k minus 1 and is restricting I plus k, I plus 2. Bruh, what am I doing here? Okay. Let's create like a let's call it find subarray, right? Let's pass in I. I think that's all we'll need, right? Let's leave it as a void for now. I don't know. Void find subarray. Can have just int I, right? I have some sort of loop here where we go from int start is equal to I is less than, we pass in a vector of ints reference to nums less than nums.size I plus plus. We want to let's see here, we use this as a helper function here, right? So helper function, we then find the subarray here, we call I and nums. Need a comma here though. For in I is equal to 0, I plus 2 times k is less than or equal to n I plus plus, right? We only want to keep going when I plus 2 times k is less than or equal to n. So we're still, that range that we're looking at is still within our bounds. We go I plus plus, right? We then pass the I and the nums here. We then just go from, okay, well, int start is equal to I. We don't want an if statement here. We probably want to return a bool now that I think about it. This needs to be a bool. We go, okay, well, if find subarray I nums and find subarray I plus 2 nums, right? Because like what we were looking at here, if we find the element here, this element works, right? These are its adjacent. This looks good. We go plus 2. One, 2, 3. Hang on. Go plus K maybe? Has to be plus K. Take a look here. Plus 2 times K minus 1. I do the nubs, I do start, and end. Nums I plus K. That's what I was looking at. Yeah, it is I plus K. This is the end, I plus K minus 1. Yeah, okay, that makes sense, right? So, let's do start into end, vector reference nums. I plus K, sorry. This would be I plus K. This would be I plus 2. I plus K, I plus K times 2 in nums, return false. This is true. We turn true. Else we get to false. We then loop from here from start to end. So less than or equal to end, right? If nums, what's good, bro? Mustafa, what's up, bro? How are you, man? You turn down the Spotify a little bit. If nums I does not equal nums. What are we checking here again? We're checking if it's greater than. If nums I what's up, Twin? What's up, Stuart, dude? Hi, at it. Yeah, what's up, guys? How's everyone doing? Working on the daily problem from yesterday. Trying to think here. So if we pass in the element that we're looking at, right? In this case, we're passing in I and I plus 2, right? So we're looking at this element here, starting from I is equal to 1. Pretty good. We're stuck on Firebase auth in the back end these past few days. Finally connected my front end and it works. Let's go, dude. Type shit, bro. Nice job. Just chilling. That's good, guys. That's good. I'm chilling too. Doing a little bit of Leetcode. Working on the daily problem from yesterday, so. I think here this can go from I is equal to 0. right? Because I think we can check from this element, right? We then keep checking the increasing, right? And then we check in this color, we go I plus 3, then we check from here 1, 2, 3. If this works and this works, then we know that this is true. I think that's the goal. I don't think that B in front of it has to be greater than, so I think I'm just gonna go with num's I is less than num's I plus 1. I plus 1. If num's I is greater than, we can return false. Return false, otherwise everything is good here. We just return true. Right, if we pass in 0 here and we pass in I plus 2. Yeah, we'd want to include that. Yeah, so it should be less than or equal to. I don't know, maybe this will work. Let's see, dude. I don't know. What am I missing here? Expected. I think I'm missing an extra parenthesis here. Let's see what's happening here, bro. Okay, no. For start is equal to I. This should be int I. Equal to start. Yep. Looks good. Okay, so we turn false here. So I'm doing something wrong here. I feel like I'm thinking about it correctly. Seems right. Int I is equal to 0, I plus 2 times k, right? We're making sure that that distance works, right? I plus 2 times k is what we need to check, right? Let's see here. 3349, Jason increasing. This looks correct to me, bro. What am I missing here? We'll go out of bounds. Wrong end calculation. I plus 2 should be I plus k. I had the right thought process, but I just... Yeah, this should be I plus k. What am I doing, dude? I plus k. I plus k times 2. Times k. I plus k, I plus 2 times k. Turn true. For int I is equal to start, I is less than end, I plus plus. And this should be n minus 1. Why am I making these changes? I don't know. Nums I is greater than or equal to nums I plus 1. We return false, otherwise we return true, so this should run. Alright, but why did I make those changes here? Incorrect range, you're checking I is less than or equal to n, but then accessing nums I plus 1, which will go out of bounds. Wrong AND calculation. I plus 2 should be I plus K for the first subarray. Wrong AND calculation for the second subarray. I plus K times 2 should be I plus. Right, I being where we're at, it should be 2 times K. So we're getting 2 of that, yeah. We start at I, go to I plus K, then we start at I plus K, go to I plus I 2 times K, turn true, and we start looping. We go from start to I is less than n minus 1, I plus plus. If nums I is greater than or equal to nums I plus 1, we return false. That makes sense. For strictly increasing, yeah. Interesting problem. Man, let's take a look at the daily problem from today. Array nums and it is used to find the maximum value of K, which there exist 2 adjacent subarrays of length K each, such that both arrays are strictly increasing. Check if the 2 subarrays of length K starting indices A and A be where both subarrays strictly increasing, the subarrays must be adjacent. Maximum value of K. The 2 subarrays are adjacent and 3 is the maximum possible value of K for which 2 such adjacent arrays are strictly increasing. I'm a little bit confused what this is asking. Oh, okay, I understand. You're trying to find the maximum value of K, for which there exist 2 adjacent subarrays of length K each, such that both subarrays are strictly increasing. Sure, the 2 subarrays of length K. See, we're pretty much just returning K here, I think. Binary search. I had a feeling it was binary search. I had a feeling that's what it was. Because I was thinking you could probably do this trying everything. I had a feeling it was binary search. Trying to think how we would do this as binary search, dude. Like, does that mean we have to technically sort this input here? I don't know. Didn't think of binary search, just use a simple sliding window approach. Maybe we can do this using a sliding window. We go 2, 5, 7, 8, 9. We get the 2. We then move this forward. Keep checking. 5, 7, 8, 9, 2. We keep moving the left pointer, right? We go from 7. No, what's the algorithm here? We go 2, 5, 7, 8, 9. This is strictly increasing. No, technically that's correct, right? But we need some sort of condition here. That's what I was thinking for the last one, but let's just kind of start putting down some code, right? So we want to return an int here. Think of a sliding window approach, right? So we need like an int k, right? Int left is 0. Right, it's less than or equal to less than plus. Alright, so right is less than nums.size. I++, so maybe we keep going. I'm trying to think about this, like I have these numbers here. How can we represent this though? We grab the window here, right? We keep going as long as it's increasing. When it's not, how do we know how far to move left? It's not increasing. We don't want to move left to be here, right? Think about this logically. How far would we move left? Because we need left to be here, because then this is the valid array that we're looking for. We don't know what k could be. Damn, dude, I'm not sure. Two arrays, one from left, another from right. I have to stimulate the array. Two equal parts. Does this make sense? Split the current valid subarray into two equal parts. Look at the previous valid subarray and compare it with the length of the current valid subarray. I don't understand this. Zero 5. Split current. 1, 2, 3, 4. Length 4. We keep, if it's increasing else. Option 1, split the current subarray in half. Option 2, we take the minimum of prev length, current length. Max K. I don't get the solution here. Let's think about this, right? So we have this subarray here. We don't know. We're looking for 6. 6 is the magic number, right? In this case. Well, we're outputting 3, right? Okay, so 3 is the magic number here. Ow. Yeah, 3 is the magic number here. So we keep increasing, right? We increase 1, 2, 3, 4, 5. We get to 6, right? This is the else case. So we take the current length, which is 5. So 1, 2 is equal to 5 divided by 2. I think it rounds down, right? Does C++ round down? Division. Okay, that's what I thought. It does round down, right? So we get 2 here. This would be 2, right? Otherwise, our second option would be to take the previous length and current adjacent subarray. So Previous length here and current length. Previous length is 0. Plus the current length. So we got 0 here, right? So we take 2. Then our previous length would be 2. Previous length would be 2. And we set back to our current length, right? We'd continue. Right, to our current length. What happened to your lamp? Oh, dude, it's behind me, bro. I'm too locked in right now, dude. It's too dark. Too locked in to this problem. We set this to be 1. Right, we keep increasing. 3, 4. We see we decrease here, right? At this element here. We have this length here. I'm too locked in at it, yeah, I'm too locked in. Breakpoint, right? 5 divided by 2 is 2. We split this into 2, 5, 7, 8, 9. Option 2, min previously. 0, 5. 0. Max K is 0. So it's 2. Update for next subarray. Current previous length is equal. Previous length is equal to current length, which is 5. Current length is 1. Max K 2. We keep going. 6. So 3, 4. Yeah, 2, 3, 4 here. 4. Current length 2, 3, 4. Breakpoint. We see the 3 here. Single once we get 1. Option 2, 5, 3. Option 2, the min of previous length and current length is 5. Current length is 3. 2 adjacent subarrays. What an interesting solution here. Int n is equal to nums.size, right? We then want to go for int I is equal to 0, I is less than n, I plus plus, right? If nums I is greater than nums I minus 1, right? Then we increase our current length by 1, right? So we have our int current length is equal to int max k is equal to 0. We need a previous length. This starts at 1, right? We just increase our co-length by 1, else, right? This here is a breakpoint. right? When it is a breakpoint, we have option 1, right? Which is int option 1 is equal to the cur length divided by 2. Then we have option 2, which is current length. Option 2 int option 2, which is current length. No shit, dude. Oh my gosh. What do we want to do here? We want to take the minimum stud min of the previous length, prev length, and the current length. Max K, we want to be the min of max K, max K, max K, max, let's do stud max, option 2. These are such smart approaches, dude. I would have never been able to make this up on the spot. Stud max, max K, stud max, option 1, option 2. Current length divided by 2, right? Because then we know we take the minimum of that, right? We then have option 2, which is the minimum of the previous length and the current length, right? And then we go max K, stud max, max K. Stud max, option 1, option 2. We want to take the maximum because we want to keep increasing with the largest one, right? Of option 1 and option 2. Here outside of our loop, we could have to be equal to cur length over 2. We need to redeclare this out here. And option 2 is stud min, prev length, current length. And we take our max 2. Max K is equal to stud max. Max K is stud max, option 1, option 2. Prev length is equal to cur. Return we don't need that. We just need to return the max K. Unassigned offset. What does this error mean? Because you're accessing an array out of bounds, the issue is likely out of bounds. Where am I checking that it's out of bounds? I don't know why I'm checking the out of bounds. Oh my gosh, dude. I thought I was starting at I is equal to 1. Where was this coming from? Oh my gosh, dude. There we go. Okay. Okay. Is this interesting approach? I just would have never thought about that, right? It's like you're taking the half here, right? You're taking the lower side, so this is 2. Right? You keep going. You find this here. Let's take a look here. Previous length would be take option 1, which would be 2. In this case, it would be take the minimum here, which is groove length and cur length. Groove length is 0. And you want to take the max of these, right? The max being, yeah, option 1 being 2, option 2 being 0, right? Then we come back here. We set our max K to be 2. We keep looping, right? Max K to be 2. Keep looping. Go to here, right? We keep looping. We get 1, 2, 3. We go from here. Then we go, okay, well, current length is 3 divided by 2, which is 1. Then we take the minimum of that, which the previous length is 5. Current length 3. Then we have 3. Then we take the max of option 1 and option 2. So our current length is 3. So that works. 2 options. K is equal to min 5, 4. We can split, or we can take the previous length and the current length. So our previous length is 5, right? That's fine. We're taking the minimum of that, being 3 in this case, right? So then we take the max of option 1 and option 2. Max K. We're like, damn, man. I understand now, dude. I think I could have solved that. Maybe. Dude, it's tough. I need to think about it more. I need to spend more time like thinking about the approach here in these problems. I guess I'm just kind of tired, to be honest, but yeah, I guess that's some Leetcoding for tonight. Appreciate you guys watching. Peace, guys.